And here we go. So use the spinner below to answer the following. Let me just give you some perspective. I could have just told you, imagine a spinner. The spinner has one yellow section, two green, right? I could have just listed the colors for you. Same idea. In this case, you've got the spinner, you've got the picture. So sometimes the province gives you a picture, sometimes they don't. So you got to be comfortable. You'll see both anyways when we go through this. First and foremost, folks, when it says odds, do not put a fraction down. That would be, if you could make a little note to yourself in your study sheet, odds, it has to have a colon like this, or else you'll get it wrong right away. Okay, like you won't even bother marking it. Okay, so if it's green that we're wanting, of green, so it's odds of green. That means you want green, the number of green here, and this is not green over here. So you go find the green sections. In this case, we've got 2 greens, and over here we've got 6. However, I will tell you how I would suggest you do this. There are 8 total, correct? I make a note of that. So the way I'm going to come up with this is 8 minus, I'm going to use a red pen for this one. I'm going to take away the 2 that I've already used up. So I'm left with 2 to 6. Yes, you can reduce this. This is technically 1 to 3. It doesn't matter. Okay, technically you stop there. If you reduce and you get it wrong, you will lose marks. So don't reduce unless the question asks you, which will be never. Okay. Here's where reducing might be necessary. This is the one thing I can think of. The province gives you a multiple choice. And they say, they give you this scenario. They give you this wheel, and they say, which one is a correct odds? Which one would be the correct odds that says how many times you expect green for it to land on green? The odds in favor of green. They may have the reduced version of the odds among one of the choices. Oh. That actually I think happened once, but it will be small enough that you could probably figure it out. Okay. Anyways, so I will do the odds first here. Okay, the odds of landing on red. So that means that you want red first, and the other is just not red. You just don't want red on the other side. So you look it up, and you have 3 reds. And obviously it's 5, right? So I'll go 8 minus the 3 I've already used. So remember, I focus on the event and then I take it away from the total to get my other number. 3 to 5. I hope that helps you. Okay, sorry, can't see that. 3 to 5, and then I'll do the odds as well. Watch this. Odds against, what's the event? Yellow. When it's against, then the event itself, which is yellow in this case, goes there. That means that not yellow is going to come first. That's what against is saying. Okay? So we have one yellow section, and you should know that this is going to be 7, but I'll go 8 minus 1. So that's 7 to 1 would be the odds against landing on yellow. Okay? Next. The odds in favor of the spinner landing on yellow. So because it's odds, we know it's like this. In favor or of, it's the same thing, landing on yellow. We want yellow here, not yellow there. I've already talked about that same event before. It was just flipped. So I'm just going to turn these numbers around. Right? I already know yellow, not yellow. So I'm just going to flip that other one. Yeah. Go ahead. Okay, so those are your odds. Now let's talk probability again. That's what we started with. Okay, so let's go to 17, and I'll do B there. What is the probability? I want you to have a fraction, right? I want you to think of probability is going to be a fraction, and you have the total always. Okay, it compares the favorable to the total. Odds does not have total in it, guys. It's just in favor and against, right? It compares the events happening and not happening. That's what odds will do. Because I might ask you this on an AC or two. Okay, what's the difference between odds and probability? Probability compares to the total. Odds compares the event happening and not happening. Okay. Spinner landing on green. We've got 2 green sections, so that's it. 2 out of 8. And remember, you could have come up with. Sorry, I don't know why I did that. Right? You could have come up from the odds. You could have stated your probability. I need you to know how to do this. Right? We know that to get our bottom number, we need to add these up. So it's 2 plus 6. Okay? And it says probability of landing on green. We know that the 2 represents green. Okay? So that would be 2 over 8. The same thing. We did it the same way. Okay? So I just need you to convert from odds to probability as well. I need you to be comfortable. Because imagine this, okay? You're with me? I know it's early. Imagine I never gave you that spinner. All I gave you would have been the odds there. Hey, these are the odds of landing on green. What's the probability of landing on green? You should be able to convert it over to probability. Okay, that's a skill that I would expect you to know how to do. Next, the probability of the spinner landing on red. Probability, we can actually write down red. We have the odds here, so let's just use that. So it's 3 plus 5. And we know that the 3 represents red, so that's what we want. So that's 3 over 8. Okay, just use the odds to turn it into a probability. You could have verified with the wheel, but that's okay if you didn't. Next, odds against landing on yellow. What's the probability against the spinner landing on yellow? You basically are asking for this. Right? And I will use the odds of yellow, of not against yellow, sorry. So that's 7 plus 1. And we know that not yellow is my first number, which is 7. Okay? So that'll be 7 over 8 is your probability there. And the probability of a spinner landing on yellow, probability of yellow is 1 over 8. Because remember, the probability of something happening and not happening always adds up to 1 or 100%. Okay? So that's that. I'm going to go to 19 now. And you're like, what about 18? If time allows, I might come back to 18. Okay, if time allows, I will try that. But let's go first to 19. Example. Below are the choices of donuts at a birthday party. The donuts are in a box, and each guest must close their eyes and pick a random donut. Otherwise, this wouldn't work, right? You literally have to grab a random donut for probabilities to work. You've got 8 Boston cream, 5 chocolate dip, 4 honey dip, 3 apple fritters. I went to 2 different Tim Hortons yesterday, and they were all sold out of every single donut I wanted. I'm like, what's going on here? I wonder if they know it's Halloween, right? So they don't make as many donuts because people get their candy elsewhere or their sweets. State the probability of someone randomly picking a honey dip donut. Again, I want you to highlight because I'm mixing this up on purpose. It's probability. We're talking about probability. So probability of honey dip, we need our total. So we're going to go 8 and 5, that's 13. 4 is 17, 3 is 20. So total is 20, okay, 20 donuts. So we know we're going to have the total here. That's what probability does. It compares to the total number of possible events. And we want honey dip, so we know it's only 4. I'm just going to leave it like that. You could have turned it into a decimal. You could have simplified it. Can we simplify? Let's do that. Divide it by 4. Divided by 4, this gives you 1 over 5. It's the same answer. Both are acceptable. 4 over 20, 1 over 5. What does it say next? Yeah. No. I think sometimes my ACs ask you to do it, but I don't think I'll require it. If you see that, you can safely ignore. I showed you how to do it with a calculator, right? How to simplify. Did I? Some of you are like, I don't know, I think I was sleeping right about that time. So you go 4, I have that AB button right here, A, B slash C, that's a fraction, so 4 over 20. If you hit equals, it simplifies it to 1 over 5. So that's why the province doesn't give marks for it anymore. State the odds of someone randomly picking a chocolate dip donut. So it's odds. So right away, you're going to do this. So odds of, right, in favor of what? Chocolate dip. Let's call it CD. That means that you're going to compare chocolate dip to all the donuts that are not chocolate dip. Okay? Please think of it that way. So how many chocolate dip do we have? We've got 5. And on this side, guess what I'm going to do? I'm going to say, well, I have 20, but I don't want to use those 5 that I've already used up. So I'm going to go minus the 5. So it's 5 to 15. Can you simplify that? You can actually. I will just show you just in case. 5 goes into that once. 5 goes into the 15 3 times. So that would be the simplified version of the odds there. It's the same as fractions, guys. Divide both sides by the same amount. Next, state the, because I'm going to do this to you, back and forth, and the province will do the same. Odds, you know it's like this. Please use words before you use numbers, because I think that's going to save you a lot of grief. It says against, correct? Someone randomly picking a Boston cream donut. That's the event. Because it's against, we're going to go Boston cream goes here. Therefore, we're going to have the non-Boston cream donuts up front. Remember, I focus on the event itself. So how many Boston cream do we have? We've got 8. Then I go and do the knots. Okay? 20 minus 8. So that is going to be 12 to 8. That would be the odds against. Okay? Does the state the probability against someone randomly picking an apple fritter donut? We're back to probability. Okay? So read carefully. So what is it asking? Probability against apple fritter, like you don't want apple fritter. We know there's going to be a 20, right? We always want the total down here. Can I just make sure you understand total? I will also go back to A. I'll also go back to A and make sure you, when you flip through your notes, you understand that the total is there. Okay? That's the unique thing about probability. We do care about the total. So what goes up here? We don't want apple fritter, correct? So remember, not is takeaway. So I'm going to go 20 minus apple fritters, right? There's 3 apple fritters. So that's going to be 17 over 20. That is the probability. I could have asked you as a decimal percent, but we're not going to go there right now because that's not the point right now. The point is, if you can come up with these 2 numbers, we're doing pretty good today. Okay? I'm thinking if I should do 20. I think 20 is a very important concept. I don't know if you got there, but make sure you write this down correctly so you have your examples down, okay? So if I asked you on Monday, using your own words, what's the difference between probability and odds? I don't know, Mr. Dirksen, it's something like, I don't know, maybe let's try to simplify it. Odds is something happening, something not happening. That's what it compares. Probability is something happening versus the total. If you can remember that, maybe add that to your study sheet, then you're fine. That would be an acceptable definition. Page 20. And I'll bombard you with it over and over. Like by the end of this unit, you'll know to say that. This one might give you a little headache, okay? So you gotta watch out. I'm gonna try to break it down for you. The odds against Mr. D giving an AC on any given day are 2 to 3. Let's break that down first. Just this one right here. If I were to say odds against giving an AC, AC is the event, right? I know that this number right here is AC because it says against. So the event goes on this side, and this is not giving an AC. Can you see that up there? Because of that wording against, we put the event here, and this is not happening, right? No AC. So we can put the colon there. So these numbers, that's what they represent. AC is 3 and not AC is 2. So in 5 out of 5 days, right, 3 and 2 is 5, you could expect an AC 3 times and not getting an AC 2 times. It's a little extreme, this example, but hey, it is what it is. A student sees this and claims that it is unlikely that Mr. D gives out an AC. Is this claim correct? State the probability that an AC will be given on any given day, fraction, decimal, percent. So you're going to go probability of you getting an AC. Remember, if I gave you odds, how would you come up with the bottom number? Add them up, yeah. So 2 plus 3 for sure. And then you have to know which number to pick. Which one talks about ACs? Is it the 2 or the 3? It's the 3. So the 3 goes up there. Geez, right? You're like, thank you. Thank you for ruining my Friday, Mr. Dirksen. Everything was going well until you had to bring this one up, right? What is that as a decimal? 0.6. 60%. Would you say it's more likely than unlikely that you would get an AC based on this?
I think it's more likely.
It's more likely because it's more than 50%. So that student is incorrect. Right? It's incorrect. The student is incorrect. Since the probability of getting an AC is above 50%. That would be your answer. And I will just say in moving forward, 0% is impossible. I don't know if you remember me saying this. I did have that in a little note. 100% is certain, like certain that you're going to get an AC, right? It's absolutely 100% sure. 50 is what we call fair. Okay, 50% would be fair. That's why your weather forecast will never have 50% probability of rain 50, because then you might as well just toss a coin and figure it out yourself, right? It's a 50-50 chance. So they always go either 40 or 60. Like, I don't know if you've ever followed the forecast, but this is likely, and this is unlikely. Or not likely, right? So that's kind of how it works. So this is just for your information. I think everybody would see that, be like, yep, I get it. It's more than 50%, so it's actually more likely to get an AC than not. Let's do this trigonometry, and then I think I just have to move on to the next concept. It's just going backwards. It's going from from probability to odds, going the other direction. So consider the word trigonometry. If the letters will be placed in a bag, determine the probability. Highlight that word, okay? It's the probability of drawing a T. So probability of drawing a T. What do we need? I would argue find your total, guys. Find your total. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 letters. Yeah, that's our total. Okay, so we're gonna put 12 down. How many T's do we have? 2 T's. Yes, that would be it. We can reduce it, right? They're both even, so we can divide both of them by 2. So that's 1/6. What would that be as a decimal? 1 divided by 6. That'd be 0.17. If you multiply that by 100, and you round that to 2 decimals, this would be 16.67%. The odds of drawing a T. The odds of T. Remember odds? You have to have one of these. Colon, right? The first, it's odds of this happening, of drawing a T. So this is T. Therefore, this will be not drawing a T. So we know that we have 2 T's, and therefore 12 minus 2 so this would be 2 to 10 would be the odds in this case. Remember, if you add these two up, you get your 12, right? That's something you should check. If you do have the probability, if you do have your total, you should be able to add them up and get that total. The probability of drawing a vowel, there it is, probability, so I'm mixing it up, okay? Probability, so probability of vowel, we've got 12 total, and we've got I, so 1, 2, 3, 4, 4 vowels, right? The Y is not a vowel. Okay. Reminds me of this joke. I only know 25 letters of the alphabet, and I don't know why. Anyways, the odds. Okay, the odds of drawing a consonant. Consonant is whatever is not a vowel. Okay, so probability of. Oh, odds. Sorry. You know that that's wrong, right? Yeah. That's probability. My bad. Yeah, Freaky Friday. So that's consonant versus anything that isn't a consonant. It's whatever isn't a vowel. So let's do a little bit of thinking here. Logic. Let's put logic into play here. If 4 are vowels, then how many are not vowels? 8. So we'll just say 8, and this should be 4. Because not a consonant is also the same thing as a vowel. So play of words here, it's a little annoying that way. It's like losing is not winning, right? It's the same thing. Thank you for ruining our Friday. Yeah, I appreciate that. Okay. I'm gonna stop this here, and we're gonna